This will be my corrections for exam 1, question number 8. So, when we first take a look at this question, it's talking about an infinite plane with a charge density of 10 coulombs per meter squared. So once I see that without reading anything else, and we know that it's at negative 1z, so I want to draw that out. So I'm just going to use a straight line because from this would be a side view of the plane, and so it's going to look like a line. And we know that it's located at z equals negative 1 meters. Then the next piece of information we're given is that there is a surface at the xy plane, which would be at z equals 0 meters. And that plane has a surface area of 4 meters squared. So, really I should draw this a little bit shorter to represent that the first plane on the bottom is infinite. It's going to go on forever. So that's important because it means that there's not going to be any electric flux coming from one direction or the other. For example, if the plane did end right here, these were the two endpoints, and maybe the 4 meter squared piece was a little bit offset, then it could be experiencing more electric flux coming from here that would not cancel out from the other side. However, because the plane is going to be infinite, it's going to all cancel out. And so it doesn't actually matter where this plane is located as long as it is on the xy plane. So it could be centered at x equals 2, y equals 2, x equals 1, y equals 7, x equals a billion, y equals a billion. It really doesn't matter. This plane of charge density 10 coulombs per meter squared is always going to be there. So let's talk a little bit more about that actual charge density. That's going to come from, unsurprisingly, physical charges located on this infinite plane. And all this is telling us here is that there's going to be 10 coulombs per meter squared. What that means is for every meter squared, 1 meter by 1 meter square on this plane, there's going to be 10 coulombs of charge on there. So when you have charge like that, you're then going to create electric flux. So let's just take a second and look at something different. So let's say we had a box like so, and inside of this box we had a volume density charge of 6 coulombs per meter cubed. Now the way electric flux escapes an object is it's going to equalize across all of the sides. So in this case where we have a box, there's going to be 6 different sides that the electric flux can come out of. Come out the top, right, could come forward, it could go out the back, go left, or it could go down. And so you divide those out, and you would find that each direction is receiving 1 coulomb of electric flux. Similarly, with this plane, we can do the same thing. Since it is infinite, it's not going to have sides or anything. It's only going to have a top and a bottom. So then you take the charge density, and we know of 10 coulombs per meter squared, and we know that half is going to go up and half is going to go down because those are the only 2 sides available. As a result, we know that in this entire area above and the entire area below is going to receive 5 coulombs of charge. So then, that's good to know, but we're still not quite at the end. What we really want to look at is how much of those coulombs is actually going through this 4 meters squared location. So let's look. If you have 4 meters squared sitting here, that means you're going to cover a square worth 4 meters with the surface. And similarly, you're going to have that same amount from the infinite field, because anything outside of that 4 meters is going to just go past, and it will not be going through our surface, which is really what matters. So now we're really comparing how much electric flux is given off by one side of this infinite plane across 4 meters squared. So if we want to find that, all we have to do is take the density times the volume, well, in this case, surface area, which would be 4 meters squared. And then we're going to divide by 2, since it has 2 sides and we're only receiving half. And when we do that equation out, we're going to be left with a value of 20 coulombs. And actually, for this question, that's it. You're done, and you have your answer. However, it's not always that simple. For example, if we had it differently, and you had the infinite plane here, and then your plane looked like this instead of ours. So we knew ours was parallel to the infinite plane because the infinite plane was at z equals -1, and our plane was on the xy plane, and so it must be parallel. However, if you have it tilted like this, what you need to know is that the electric flux is purely based on the side facing it. So if your angle is lower like this, basically parallel, it's going to receive most of the electric flux. But if it was more vertical like this, it's going to receive less flux. So this would be the most flux, electric flux that it's receiving. This would be about medium, and this would receive the least. So if you did have a situation like this, and let's say this was 5 meters cubed here, you would then have to use cosine and sine to find the value here, because that's what it's going to be based on. So let's say you had this and it told you there was a 30-degree angle here. You could say that cosine of x, you could say that cosine of 30 degrees equals adjacent, which would be this, over hypotenuse, which is the 5, so x over 5, aka 5 cosine of 30 equals x, and then cosine of 30 is going to be read 3 over 2, so you'd have x equals radical 3 over 2. And there's your answer. So luckily on the exam, we didn't have something with this difficulty, but if we did, it's important to realize that that's how that works. Other than that, I believe that would be all you need to solve the exam, to solve this question, and really understand the intricacies. Quick recap, electric flux is going to disperse evenly out of whatever it's in, whether that be a flat plane with a surface area charge density or a volume charge density, and that's coming from the charges within it. It's going to disperse evenly, and then it's going to go directly straight up, straight down, whichever direction, and hit a plane according to its angle. Thank you.